I'm glad you all could make it to the ACT conference, and I apologize for not being there with you, but my aged body just doesn't have the stamina anymore to keep up with the conference schedule. Right now, I just want to take a few minutes for intellectual fun and draw a fanciful parallel between Bayesian affect control theory and quantum physics. It starts with this modern parable. Imagine a room-sized box with walls, floor, and ceiling all made of metal 4 inches thick. The box has no openings except for one small doorway, and that the door for that doorway is also made of 4-inch metal. In this box is a vile device that releases cyanide gas and kills any living creature inside the box. The device is scientifically set to do this with a probability of 0.5 over an hour period. The device is set by closing the metal door. Thereafter, it's purely a matter of probability whether it is activated and filled the room with poisonous gas or not. A wicked quantum physicist puts a pussycat in the box and closes the door. After an hour, he asks you, "What is the state of the cat? Is it alive? Is it dead?" And of course, you admit you don't know. It's 50-50 probability that it's in one state or the other. "Aha," he says. "Until we open the door, carefully with the fan to get rid of the gas, the cat is superposed in both life and death. It is in both states at once until we make an observation. That is, knowing only that something might be in one state or the other state, we must consider it as being in both states at once until an observation puts it in one state or the other." Okay, this parable is called Schrodinger's cat. It's a thought experiment created by the famous physicist Edwin Schrödinger with the encouragement of Albert Einstein. Their intent was to prove the ridiculousness of certain interpretations of superposition in quantum physics. And they were going to do that by having listeners to this parable draw the obvious conclusion that the cat in the box always was in one state or the other, either alive or dead, never both. Now, Schrödinger and Einstein actually slipped up a bit on this issue. Over the last several decades, physicists obtained experimental evidence that superposed states really do simultaneously exist at the quantum level. Even the case of the cat in the box isn't all that clear. After all, were I the caretaker of the cat, I would have to consider it in both states, alive and dead, in a practical sense, in that I would have to have a can of tuna ready for when the door was open, and I would also have to have a body bag. Okay, let's turn away from felines and physicists and go to our own world of identities and Bayesian affect control theory. Specifically, I want to consider part of the award-winning article by Tobias, Jesse, and Kim on modeling dynamic identities and uncertainty in social interactions. I propose that when an individual has substantial probabilities for alternative identities, the identities are in a state of superposition. Moreover, superposed identities all are salient at once until an action collapses the probabilities into a unimodal distribution favoring a single identity. An action also could create a new superposition of different identities. In social interaction, actions work like observations do in quantum physics, collapsing ambiguity down to specifics. For instance, a person who doesn't know which of several identities she has in a situation superposes the possibilities and is equivocal about who she is. In the award-winning article, there's the example of the woman who is both employer and daughter to her female partner. Her two superposed identities leave her in a state of ambiguity until an action selects one identity or the other. I haven't worked out whether any more analogies exist between quantum physics and Bayesian affect control theory, but there are interesting possibilities to consider. Most notably, the mathematical framework for quantum physics provides a more general probability theory than the one we all know. In the framework of that more general theory, the same events occurring in different orders can lead to different outcomes. Were I 40 or 50 years younger, I'd dig into all this and see what happens. However, being an old geezer, I wouldn't get anywhere, and I'm not going to try. If you're interested in seeing how a more general probability theory would impinge on affect control theory, there are good resources for you to turn to. In particular, a mathematical psychologist at Indiana University named Jerome Bussmeyer has provided a treasure trove of helpful materials. Just go to his IU website, and from there, go to his quantum cognition website, and you'll find expository materials as well as intriguing research articles like this one. Empirical comparison of Markov and quantum models of decision-making. Okay. For me, raising intellectual questions and answering them is about as much fun as I can have. In that context, I urge all of you at the conference, have fun.